So we're back working on this 2013 F150 with the repeated BCM failure. And I've got a case posted on the International Automotive Technicians Network, which is a subscription service available to technicians around the world. And several suggestions have come back to qualify the grounds on the BCM, which I had previously done prior to replacing the third BCM. Pin grip on the BCM grounds and various terminals. I believe I checked it because I've done so much on this I can't remember specifically checking pin drag, but I'm going to do that. There's a couple of grounds here. There's a ground on this A pillar right here that looks pristine, and over on that A pillar on the passenger side, I'll show you where that is. So there's another ground on this A pillar. And that comes to this main connector at the BCM here. So we're going to qualify these grounds. I'm going to take them off and clean them anyways. That one and that one. And then there's one up inside here. I'm going to take that one apart and clean it as well, even though I can't see anything wrong with it. And I had tested it, load tested it previously. In my opinion, what can kill an electronic module is a power surge, a voltage spike, a bad ground, or physical contamination from moisture entry, water entry. I've looked underneath the carpet. This is just sand in here. There's no rust in here. There's no evidence of water leaking into the cab of this vehicle, although I saw a video where water was trickling down from the heater vent here. But I think the windshield had a hole in it and water was simply going into the heater vent. And the dealership probably tried to use that as an out to deny any further coverage on the parts warranty of the BCM. They replaced one BCM here. It failed within a day. They replaced it a second time. It failed again, and then they saw the water entry from a hole in the windshield, a stone hole in the windshield up in this area, I believe. So let's have a look at the schematics. So here's the Mitchell wiring diagram showing a portion of the circuits going into the BCM. And here we can see two grounds. This one's on the left A pillar, left side of the dash, and this one's on the right A pillar, right side of the dash, the ones I showed you inside. They go to pin 16 and 25, I believe. Here is a picture of the connector, 16 and 25, which is this large rectangular connector with the lock on it, this one here. I just happen to have these from a previous BCM that the salvage yard sold me, and they cut the connectors off. So one of these terminals here, which would be likely this one, well, you can see the two wires I had tied together are both grounds there, the black and white, or black and yellow. So those are the two grounds. Power supply comes from the main heavy bus bar going into it. Now, if you watch the previous video where I took this BCM apart, I figured out that by removing this one fuse here, this fuse number 18, from a good BCM, I would lose the voltage to all those pull-down circuits. So fuse 18, if you look at a schematic for fuse 18, supplies all these field effect transistors, and it also supplies the brake transmission shift interlock solenoid. So I wondered if there's any solenoid would typically have a diode across it. So I'm going to have a look at that to see if there's a diode in this solenoid. So here's another portion of the diagram showing the column shifter, because this has a column shift. So from fuse 18 it goes through this field effect transistor and off to the shift interlock solenoid, you can see here. Now it shows a resistor in parallel to the coil, and sometimes they do use resistors, but usually only in a relay, so that's kind of odd. The interesting thing is, if you look at the floor shift version of this, which I'll pull up here in a sec, it does use a diode. So here is the same circuit, but this time using the floor shifter. So there's fuse 18, goes to that brake shift interlock field effect transistor, out circuit CET53, this blue-orange wire, and it goes to the shift interlock solenoid in the gear shifter if it was a floor shift. And you notice there is a clamping diode in there. A clamping diode absorbs the voltage spike, or redirects the voltage spike from the coil back into the coil itself so that it doesn't go back and spike this transistor. Either that diode could be ineffective or open circuit, and it might be spiking that transistor, which is fed by fuse 18, which seems to feed the internal circuitry in the BCM for all of the pull down circuits, because that's what happens to this thing. All of the pull down circuits that are simple switches that ground the circuits, they all go to like less than 1 volt. So the BCM thinks all the switches are closed. Let's have a look at that circuit. So here, for example, is a diagram that shows the power or the door jamb switches or door switches, and it shows this circuit for the left rear door goes through a normally open switch and closes when the door is open, so it pulls it to ground when the door is open. So a short to ground on here would be the same as the switch grounding it. So it's not a short to ground on any of these circuits, because that would simply activate the circuit the same way the switch does. Let's see if I can find the actual hazard switch. Here's the hazard switch. So all this switch does is connect this to ground, and it pulls a voltage which should be greater than 10 volts from the BCM down to ground. The low brake fluid level circuit is exactly the same way. Here's the low brake, or the brake fluid level switch. So these two circuits come from two wires at the BCM. Greater than 10 volts simply get pulled to ground by the brake fluid level switch. Parking brake switch, same circuit, same idea. 10 volts from the BCM, 11 volts from the BCM, pulled to ground. So a short to ground on there would just simply simulate you having the parking brake on, and would set a fault code for that, or turn a message on the dash. Every one of these pull down circuits is dead. They all measure less than 1 volt, and they should be greater than 10 volts according to the diagnostics. And on a new BCM or a new used BCM, as soon as I plug it in, everything works electrically. Here is the, well, that's the door jamb switches I just mentioned. But every circuit is like that. Hood ajar switch, parking brake warning switch, and so on. So they're all pull down circuits. So we're going to check those pin drags. We're going to clean those grounds. We're going to put it back together again, and we're going to try and establish whether there's a voltage spike from this brake transmission shift interlock solenoid that could be causing the issue back to this pin here. So we're going to monitor the voltage on that circuit and lab scope it or graph it and see if we see any voltage spikes when we're moving the shifter. If there's a voltage spike, then we're going to put a diode across this. Now it's interesting that this doesn't show a diode, it shows a resistor in there, so whereas they show a diode in the floor shift model. So the two grounds on this plug are this one here and this one here. So at the BCM, we're going to use this test terminal, which is the exact right size, to check pin drag on there. It feels nice and tight. Might as well check them all to feel there's no pin in that one. And then the smaller pin, this size here, is for this terminal. It does feel pretty positive. There's no pins in there. And this one. So these pins all feel pretty snug. But there's only the two grounds that I can find in here. This one here and this one here. And they both test good. Now I've taken apart the grounds at the pillars here and die grind them or cleaned them with Rolox sanding disc, as well as the one on the column, and taken the BCM out. I don't see any other ground pins on this BCM. This is a third used one. Well, we're going to continue to put this back together again. There's absolutely no signs of water underneath the carpet. I've had the carpet off. Well, we'll clean it up and put it back together. So it's all back together. I cleaned all the grounds. I cleaned the grounds, body grounds by the battery as well. Of course, hazards work now with a donor BCM in there. I haven't programmed it to the vehicle. Power locks work. I've got a bunch of messages related to low oil pressure. It's not running and the key's on, and the tire pressure monitor isn't programmed, but that's the issue. Now I'm actually looking at the brake transmission shift interlock solenoid. I've got a voltmeter connected across the solenoid. Try to get the glare off here. And I'm stepping on the brake. So there it energizes, de-energizes. And every once in a while you get a significant voltage spike. And that's what that clamping diode is designed to fix, so to speak. So that voltage spike right there is designed to fix it. So I'm going to back pin it down at the PC or at the BCM on the circuit involved, which is pin 49 at connector 2280B, which is the bottom connector at the BCM, and pin 32 in that connector is a hazard switch. So I'm going to see if I see a voltage spike on that hazard switch circuit at the same time. So I tried it a couple more times here and managed to capture one voltage spike right at the solenoid of negative 16 volts. And that's when the solenoid collapses, when the magnetic field on the solenoid collapses. Now it's interesting that the column shift doesn't apparently use a diode, it uses a resistor in there, whereas the floor shift uses a diode. Like I said, we're going to back pin at the BCM this same circuit to see if that voltage spike is down there and see if it shows up in the well, we'll try the hazard switch circuit because that's one of the circuits that's affected, where the source voltage from the BCM gets lost for whatever reason. So I got a dual channel voltmeter, graphing voltmeter connected. The yellow channel is connected to pin 49, which is the brake transmission shift interlock solenoid down at the BCM down there. I took the covers off the back of the terminal so I could back pin this connector here, pin 49, and I've also got the green trace on the hazard switch. Notice if I press the hazard switch, it drops to 0. It's just a pull down circuit, as I mentioned. Now on the failed BCMs, this voltage drops to like 0.5, and then all of the circuits fail the same way, fail low voltage. That's why it's indicating the doors are open and everything when they're not, because they're all at low voltage. So watching that brake transmission shift interlock solenoid, there it's on, there it's off. So you saw the voltage spike there. Let's pause this, see what that voltage reached. Drop cursors on there, and where cursor number 2 is, the voltage actually hit negative 5 volts. Well, I did capture one at 16 volts, but I don't see it affecting the voltage signal on the other circuit. The green trace voltage doesn't change. Well, just to be safe, I'm going to put a diode across that shift solenoid up inside the steering column here, because I know it'll eliminate that spike. That same fuse 18 feeds that brake transmission shift interlock solenoid, and that fuse, if I pull it out, kills the reference voltage to all of these circuits. I'm just going to confirm that on this BCM that's installed in the truck. I'm going to pull fuse 18 and see if I lose that voltage. So as I mentioned before, with fuse 18 removed, I lose that reference voltage to all of those pull down circuits, and the brake transmission shift interlock solenoid doesn't work. So it's a stretch that that voltage spike is damaging the driver inside the computer, but I can't find anything else. So I know I can eliminate that voltage spike by putting a diode across there to suppress it. So let's do that. So here's the 4-wire plug to the brake shift interlock solenoid right there. So we're going to put a diode between this blue-orange wire and the black wire, just like an AC clutch compressor, cycling clutch suppressing diode. So I'll see if I can find one. So there's the diode soldered in the correct polarity. The negative end of the diode should go towards the positive end of the circuit. The negative end of the diode is indicated with a little line on it. So I've got it soldered in there. I'm going to put some butyl tape over top of this so that it doesn't short out or touch each other. Plug it back in and we'll reassess the voltage spike. Okay, so I've got the diode installed. So you can see the circuit turns on, turns off, turns on, turns off. Now there's no voltage spike on that circuit, and I'm measuring it going into the BCM. You also don't see any reaction to the 11.6 volts. So I'm gonna initialize this module so the truck will run. That means doing a module parameter reset. I've already programmed the keys to this module, so I should be able to, it should run with it. It just has to be married to the PCM, and then we'll see. I'm going to drive it for a couple of days with that module in. The heater controls don't work, but everything else worked fine, so hopefully I can drive it like that. I'm really starting to hate this truck. Now I got it all back together again. I tried to do the PATS relearn and it aborts because of an error. I do a network scan and I've got no communication with the PCM, no communication with the ABS, OCSM, I think that might be occupant constraint, and restraints control module. So I've got the breakout boxes installed in here. I got the power off, and I'm measuring terminating resistance across pin 6 and 14 of the DLC, and it reads 120, so I have an open circuit. I double checked to make sure I hadn't forgotten to plug in a connector at the A-pillar and down here, and I can't see anything I missed, but I'm pretty sure that that goes through this big connector here. Let's try wiggling this connector. No difference. Well, let's unplug that and see what happens. So now it's 61. Watch what happens if I move the connector. Now it's not going to do it. So I'm going to take this connector apart. There it goes. And I'm going to put some electrical enhancement stabilitant 22A on the terminals for the CAN bus. I had a picture perfect CAN bus signal. And we're waiting the 10 minutes to gain access to security now, so the PATS system seems to be opening up. We'll see. I don't want to jinx it. So my thought now is to road test this vehicle back and forth to town for a few days while monitoring two voltages. I'm going to monitor the run voltage here on the yellow trace. That's battery voltage. That would show me if the charging system overcharges or something. And the other circuit, I've got it actually connected to pin 15 here, which is low brake fluid, one of the regulated voltages that's pulled down by a circuit, same as the hazard warning and the door ajar, and I just picked that one because it was convenient to get to. They all fail. Got no warning lights on except the driver's door ajar. Hazards work. Now the problem with this the problem with this particular BCM, it's not correct for the vehicle, and the heater controls don't function. So they're stuck on, I can't turn them off. can't control the fan speeds, and I got a communication code between this front control interface module and the BCM, so I figure it's wrong. But the rest of the circuits work exactly the same as far as I could tell, so I'm going to monitor the voltages on these two circuits while I road test it back and forth to town over the next couple days. See what happens.